Hello guys and welcome back to this one. So yesterday we looked at how we build a cyclic list and from a singly linked list, and now we are going to be looking at the brute force implementation of checking if a list is cyclic, right? If a list connects back to itself, and we kind of use kind of a merry-go-round, a carousel approach here. So what do I mean by that? Now we have we hold a variable or a list called scene node, and then we call current to the head of the node we are bringing in, right? And then we say while the current is not known, so while we transverse through the list and look for none, and while it's not yet known, right? We say if current is in scene nodes, then return. So if at any situation we find the current within the scene node list that we earlier created, then we should return that value as our cyclic node, or the node that our this thing our list connects back to. And then if scene nodes, and then as we go move along, we append the the um, the nodes we find to the scene nodes. So it's just like putting stuff in a list and then waiting to see if we come back to have a value that is already in that list. That's basically it. So let us see how that works with our debugger tool. I think that's very appropriate to see how this transverses. So let's step into the list. So we have the list head called here, and we could see 750 is this thing. Now let's transverse. Now the head is being the scene list defined, the head called current, and then we transverse. Now while current is not known, no current is, we are looking at what current is not known, so it's called conditionally satisfied. We move into the list and then we continue to transverse, and then we append the first value. So we could see that here. So we could see we are at the index of 0, we have appended something, and the length of the list is now 1. Now we call current again, we go back to the top, we've moved current to the next, and then we go back to the top, and then we go again, we check if this thing is in the list. So it's not, so we move again. Okay, so we say we append that value that we haven't seen on the list. Now we are on the third one after we call current dot next to current. Now we're on the third bit, right? So we would transverse again, and we will say that, oh, is this current node in scene? We can't find it in scene, so that means we move on again, and now we have our third value, right, which is at index of 2. And then now we are going to go again to see if, because that's now our last variable, because we are doing from our this thing here, we built a cyclic list of 4, 5, and 6, and we are passing in that stuff. So basically we've gotten to the tail of our list right now, and then we call this guy, and while it's not known, now if current is not in scene, so basically we are now comparing whatever this thing is pointing to, now whatever our next is pointing to after the tail of our stuff. So this is now the designer guy. So now we click on him, we are comparing it whether we've seen it before, 5bo6, 5bo6. So we see that this is the same thing with the one we are on right now, that the current is already in the list. So, and it is in the index of 2. So when we click this, it should return the value. So now we've returned, and we have returned that guy, and we've returned the point where we how do you say, we've returned the cyclic list again. That's the head of the cyclic list. So this should be the first node in the cyclic list. Now our main concern is, oh, is our list cyclic, and what is the final assertion, right? So we could see some of the special variables here. We could see what our next is. We could see some other things here. but we are going to find out if this click, obviously it's cyclic from what we've seen, but we'll see what our function this thing says. Now let's click through that, and then we could see that yes, it says it's a cyclic, and it returns the cyclic this thing. So yes, to talk about the time complexity, so we have our time complexity to be O of n squared. So that's because of the search. So we do a if current in node search. So basically this in search is actually a linear search, right? So basically it does a linear search, and what that compounds to is an O of n squared. So the first one will be 1, second one will be 2, the third one will be 3. So basically it is for every one there is an increase by the count of the n value, right? So basically that's why we see an O of n square for the linear search that it does recursively. So basically that's why we have an O of n square search here. So yeah, so that's time optimization, and the space optimization remains n as it goes through every this thing goes into the scene node. So yeah, that's basically it for this one. Muchas gracias. Auf Wiedersehen. Tschüss.